Hello? Okay. The 13. It's already done. It's all the isomers, the structural isomers. Okay? Geo Geometry trigonal planar on each carbon, which is gonna be the shape. Okay? It's gonna be and it's gonna be also the electron geometry because it has one, two, and three domains each one. Sorry. Sorry. So it would be 24 electrons, formal charge, and the formal charge is 0, 0, 0, and you know the chlorine on the extreme is 0, 2. Now, okay, this would be the structure isomer. Instead of the 2 chlorine would be identical to the one we did. Why would it have 3 isomers? It only shows 2 on one carbon and one in different carbons. Maybe it's counting the geometric isomer too, for sure. Because one, two, one carbon here. If you move the chlorine here, it would be equivalent because it's a double bond, so it's 3. Hmm. No, no, it's 2. Okay, so let's keep on going. And it's 2. One here, equivalent. If you do, because it was the problem like cis and trans, remember? There was this was the one on the problem on the polarity. But those are geometrical, not structure. If you have one on the opposite side, you see, if you have one here and one here, in this case, this structural isomer, this one, the one that has in each carbon, it would be, I don't know if you remember, would be the cis and trans for the double bond because it rotates. So structural, there's no way they can see 3 is 2. Okay, so let's do the polarity. What do you think is going to be polar, yes or no? These two isomers, okay? It's going to be polar or not? Yes. And this one? Let's look again, okay? This. As we have to analyze each part of the molecule of the molecule as two different central atoms, right? If you analyze each one, okay, on this case, if you analyze this, this would be polar, okay? No question about it. Of course, this all would be polar. You have 3 different domains. Now here, we have a little bit of a problem. Why? Because on this side, right, on this central atom, we have, yes, a polar molecule in which these 3 are non-polar bonds. The only one is this one. And this one goes on the opposite way. So what's going to happen? They cancel each other. So the polarity, the first one is polar, the second one is non-polar. Okay, so let's draw this 3D sketch for the first one. It's trigonal planar, so you do it like this, and then you do carbon, and then you do chlorine here and chlorine here. Okay. So as I said, if you have it here, yes, it's going to be polar, and the vector is going to be here, and the resulting, oops, a little bit more diagonal on this direction, the net, okay? Now on this one you got hydrogen here with chlorine here, right? You got chlorine here. Oops. Now it's gonna depend. Double bond. Put the double bond because we cannot represent it with pi bonds. It's gonna be for you at this level. But now here, let me. Okay. Yeah. If it's like that, you can see clearly that this is gonna be non-polar. Okay, one up on this side, one on the other side. Of course, if it's a geometric isomer and this chlorine is down here, then it's gonna be polar because both of them pulling down. Okay, so that's the structure. Now N2. N2, how many? Nitrogen is 5 by 2 equals 10. So we got 10 electrons here. So it's going to be N, N. So basically you have to do 3 bonds, the maximum, because where are we going to get more electron? 1, 2, 3, 4, 5, 6. Where are we going to put more electron? 7, 8, 9, 10. Well, we can do this. We have another alternative. Put in single. 1, 2, 3, 4, 5, 6, 7, 8. Well, should be 10. 1, 2, and 6, 8. No, 2. So tired. Let's, okay. I know it's gonna be that one, but let me start since the beginning. So because I push you the right one at the beginning, and I want to do it wrong first. You got the nitrogen, nitrogen, okay? So we have 1, 2, 8. So let's place 1, 2, 3, 4. Okay, 5, 6, 7, 8. Now we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. You see what happens? So we don't have the octet. So now we need to have the octet. Let's move 1 here, okay? 1, 2, 3, 4, 5, 6. Still. 1, 2, 3, 4, 5, 6, 7, 8. Counting this one. Why don't we move this over here to see if this one can get it? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we're moving this so they can share an additional, and this one was lacking of electron to complete the octet. Now both of them have the octet. You see, that's why. And this is the structure, the Lewis structure. And formal charges, no isomers, of course. Okay, formal charges would be carbon, right? Nitrogen. Nitrogen on both are identical, so it's going to be 5 minus 3 bonds plus 2 ampere is going to be 0 on both. Excellent. Now let's go with the geometry. Geometry we have, on each nitrogen we have 1 and 2 domains. It's going to be linear, period. Both of them. The shape, linear. Okay? It's going to be both. And to draw the Lewis structure, the 3D, you just have to draw that without the lone pairs. Polarity. Is it polar or non-polar? Non-polar. Because it's a non-polar bond. Why? Because it's two identical elements with the same electronegativity. CO. CO, we did it the other day. I'm just gonna, when I gave the example, you see? The only thing is that here it says show the direction. It's linear, by the way, too, and no isomers. And the number of total is 4 plus 6, 10. So here, I'm doing it fast because linear, because we did it the other day in class. Linear, and it's going on this direction. Okay? C2H2. 1, 2, okay? The hydrogen terminals, and you have two central atoms. And this is going to be 8 because it's twice 4, the valence of carbon, plus 2 equals 10. Okay, so 1, 2, 3 bonds, it means that it's 6 minus 10, 4. We can't put it anywhere, but you know what? Carbon has 4 bonds. What if we put the 4 electrons here? And that way both carbon has the 4 bonds. 1, 2, 3, 4. 1, 2, 3, 4. Now we've done it so many times. Carbon with four bonds is gonna be the formal charge is gonna be 4 plus 0 equals 0. You know hydrogen is 0 too. Shape, linear. Isomers, no. There's no way, there's nothing else you can do. And the shape, the 3D sketch is linear. It's in one plane. Okay? Polar, no. Non-polar. Let's do the next one. CH2O. So we have only one C, and we have H, and we have O. Okay? So we got 4 plus 2 plus 6. It's going to be 12. 1, 1, 2, 3, 4, 5, 6. Before. Carbon can only have, usually has 4. So why don't we try to get the 4? We need 2 bonds more here. 1, 2, 3, 4. Okay, so before we start in anything else, when you have the carbon, unless it's the exceptions, 1, 2, you know how you know you're going to have an exception on carbon? That you cannot get more the 4 bonds anywhere. Like in the example of CO, you cannot put 4 bonds because it doesn't exist. So what else can you do here? And by the way, it's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You see why I'm saying? Because you can't do anything else. Now on this one, yes, you can put 3 on this side and 1 on this is going to be 4. So we got already 6 plus 2, 8, 9, 10, 11, 12. Okay? So formal charge of oxygen is going to be, hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, 11, 12. And 4 plus 2 plus 6. Formal charge of oxygen here. Let's check the octet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not possible. I'm doing something wrong again. 4 plus 2 plus 6 equals 8 plus 4, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I'm gonna have to stop it again. I know, I know it's right, but there's something wrong I did. Why is it that I'm counting the electron wrong? I did the same thing. I forgot a hydrogen here. So let me go back again. That's what happened when I'm too tired and I want to finish, and I'm too tired. Sorry, guys. So it's going to be carbon, oxygen on one side, right? Carbon, the central atom, and you got one hydrogen and one hydrogen. Now it's much better. 12. You got 6, 7. But we need another. We need another because we have 1, 2, 3 carbons here. We need another bond for the carbon. The same thing, but instead of a triple, we put a double because we have the hydrogen. So it's going to be 1, 2, well, it's going to be 1, 2, 3, 4 bonds. So it's going to be 8 electron minus 12 is going to be 4. Okay. See that I knew what it was and I was putting right the electron, but then when I counted, oxygen cannot have 8, so I was doing something else wrong. Okay, so formal charge. Oxygen would be 6 minus 2 bonds plus 4 unshare equals 0. Carbon, you know, for bond is 0 and hydrogen 0. What is the shape of this molecule, the geometry? We have 1, 2, and 3 domains, so it's trigonal planar. How many lone pairs, how many atoms? 0 lone pairs. So it's the shape, it would be also equal to the geometry, trigonal planar. Isomers? No, there's no possible structure isomers. And now let's do the polarity. Yes, the oxygen is different, so yes, it is polar. And let's do the 3D and show the direction of the dipole moment of the vector. And so you got here carbon, right? It's trigonal. So you're gonna put here oxygen. Remember, trigonal is all on the same plane. And here another hydrogen. That's trigonal planar. So now, where is the direction of the polarity going? This way. These bonds are not polar. Okay? Let's do acetic acid, and it says how to do it, and it says only consider acetic acid, so don't put any. And I'll tell you why not structural isomer, because acetic acid is only acetic acid. Okay, if it was another one, that would be then acetone, or would be, well, not acetone, but I'll show you. You got C OOH. So carbon has two oxygens, one here, the other one here, and the H, which is the acid, the hydrogen that is the acidic hydrogen. Now, if you put, for example, the oxygen on this side, that would be a different compound. Okay? And yes, it exists a structure because you can do this. Let's put the oxygen on this side. And here we put another hydrogen and we put the COH. That's a different compound. No, and in fact, we have to, you see, that's wrong because you need 4 bonds, and here you have 4, okay? But when you complete this, you see you're gonna need a double bond here, okay? So if you need 4, we have to take this one here, right? And this and a double bond. This cannot have a double bond because it has the hydrogen on the other side. Or if you do it like I was doing it, you see it's not gonna fit. It's not gonna work out. How many you have? 3 hydrogen plus 8 from the carbon plus 12 from the oxygen plus uh, another 4 hydrogen. 12 plus 12, 24. So it's gonna be 1. Let me take the double bond because I was saying, and you'll see that it's not gonna work. But let's finish this. We have 24, okay? And I'll go back to this one. 1, 2, 3, 4, 5, 6, 7 by 2, 14. So where are we gonna put the electrons? 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. Okay? Now, let's go ahead and look at the formal charge on this side. And we have, I'm going to have to do something here. I'm going to erase it then. We have here, I don't want to erase this because I'm going back there. We have here, right, formal charge here. Formal charge of carbon of this one is gonna be, you see, it's gonna be 4, the one carbon is gonna be 4 minus 4 plus 0, the one on the left, equals 0. Besides, it doesn't have the octet before you do the formal charge. That's true. 1, 2, 3 is 6. 1, 2, 3, 4. That's complete. 8. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, and 8. This one, all of them have the octet. Of course, the hydrogen duet. But what can we do to complete the octet here? Oh, move this to a double bond. Okay? And it's going to be 1, 2. Yeah, we can do both option. I'm going to draw it here and then I'll erase it. There's two options here, okay, in this one. Hydrogen, hydrogen, hydrogen. I know which one is the right one, but we need to get there. I want you to think and get there by yourself. Let's move it to a double bond, right? And let's do this. Let's check the octet now. 1, 2, 3, 4, 5. Okay. 1, 2, 3, 4. Excellent. 1, 2, 3, 4, 5, 6, 7, 8. And this has 8. But here comes the other story, the formal charge. Here is 0. Here you know it's 0 too. 4 carbons, 1 carbon, 4 bonds, 0 lone pairs. Oxygen here. What is the formal charge of oxygen here? Of the one on bottom? It's gonna be, formal charge of oxygen is gonna be 6 minus 1, 2, 3, 4, 5, 1 bond plus 6 unshare equals to minus 1. What's going to be the formal charge of this oxygen is going to be 6 minus 1, 2, 3 bonds plus 2 electron. And this is 6 minus 5 plus 1. Oops, I don't like that plus 1 in an electronegative element of oxygen. Can we do something else? Why don't we get rid of this? Because this means that it has 1 electron less. So why don't we get rid of this, put this here, not share it. This means that it's sharing 1 more that it shouldn't. So that means that it's giving it to the carbon. So the oxygen decides, no carbon, I'm not going to share it with you because then I'm going to have plus 1. And this means that it has 1 more. So he can share that electron with the carbon. Perfect. So what if we put the double bond here? I knew it was the right Lewis structure. So here the oxygen would be 6 minus 2 bonds plus 4 on share is going to be 0. Here is going to be 6 minus 2 bonds plus 4 on share equals 0. So to us, this is the right Lewis structure. And I'm going to redo it here in erase all this. You see how we got there? You see how we got to the carbon with 4? I tell you, it has to have 4. Or if you can't put 4, then you have to put lone pair. Okay? Now, you're going to have here, the structure would be I don't like those dots. Okay, the structure would be this and the double bond. Okay? So that's the Lewis structure. Now, if we check, all of them have 0 and formal chart. All of them have the octet. So, what is remember the central atom are still carbon. So what are the domains on this? 1, 2, 3, and 4 domains. We take it as the carbon, the other one. So on this one, 1, 2, and 3. So on carbon 1, it would be tetra and tetra, right? Because it's four domains for atom. Here, 1, 2, and 3. So on the second carbon, carbon 2 is going to be trigonoplanar. Trigonoplanar, there's no and the trigonoplanar. There's no lone pairs. Okay? Isomers. They said to consider only acidic, and that's what I was doing. Let me go back to this before I do the 3D. So if I am considering to put the O here, right? And I'm putting my, let me think. Okay. I was completing the double bond here. Okay, that's what I was doing. Now you know already that the oxygen here is the one that is taking the double bond. So that we did this. So I'm not going to go ahead and explain it again, but you know that the double bond is here. Okay? So let's check this structure for a second. And this is called alcohol. It's an aldehyde and an alcohol. So 1, 2, 3, 4, 5, 6, 7, and here remember there's another one, 8. It's 1, 2, 3. This is an H here. Remember we move it 1, 2, 3, 4, and 4, 8. 1, 2, 3, 4, 5, 6, 7, and 8. 16. 24 minus 16, 8, right? So 8. 1, 2, 3, 4, 5, 6, 7, 8. Perfect. We have the same, but you see, it's a structure isomer, and it's an alcohol is called. So that's why they're considered only acetic acid. So there's no isomer. I don't know why they didn't draw the line there, but it should be a line. Okay. Now let's finish with this one. And it's gonna be, the 3D is gonna be, you know already you got one tetra on one side and the other one is trigonal. So let's do the tetra first. Carbon here, hydrogen here, right? Uh, and then here you have the other carbon, okay? So you're gonna have one hydrogen and the other hydrogen, okay? So here, this carbon over here is gonna go one, remember this is trigonoplanar. So in trigonoplanar, you have, okay, this, okay? And this is gonna be, keep together the OH, either with a line or not, it means the same. And this would be double bond with the oxygen, okay? Is it polar? Oh yeah, it is. It is polar because you're pulling the dipole here and here. This part of the molecule doesn't have any polarity, so it's polar. Let me see how many minutes we have because then it takes so long on Angel to upload. Okay, I'm gonna stop it